Hello, and welcome to our third video on our series on the real business cycle model. In this video, we're going to be going over the consumer or household problem, choosing savings and demand for consumption. Now, we're going to start from the first three conditions that we derived in our previous video. So I encourage you to go over that first, so as not to have any confusion now. Okay. First, we're going to go over the definitions of these first three conditions, taking them literally as they come out of the Lagrangian problem. The first one we've seen before, actually in the previous set of videos in the math recap. Lambda is the value in utility of a unit of present income, and of course it is given by the marginal utility of consumption today. That is because income is valuable precisely because it allows consumers to buy more consumption. So the value of more income is the additional utility that the consumer gets. This one is relatively easy to interpret, and it's common to many models that you're going to encounter. The second equation, the one for future consumption, has more moving parts. So let's try to go at it one by one. The first thing is that the cost and benefit of future consumption are, of course, in future units. The cost is future income, and the benefit is future utility. So we first need to bring everything to present value. We bring future income to present value using 1 over 1 plus r. That's the price of future consumption in terms of present consumption. And we bring future utility to present value of utility using beta, the discount factor. So you see the marginal utility of consumption evaluated at the values of consumption and leisure tomorrow. That gives you the marginal utility of consumption tomorrow, but that's expressed in future utils. When we multiply by beta, we get discounted utils, which are in present value units. In a similar way, the marginal cost of one extra unit of consumption tomorrow is 1 unit. There is a 1 here implicitly multiplying 1 unit of income tomorrow. But 1 unit of income tomorrow is priced at 1 over 1 plus r units of income today. So this is the cost of future consumption in terms of present income once we discount it. Now, because we're comparing with utility, we need to multiply by lambda. Lambda gives us the price of income, how much we value income in terms of utility, so as to get the cost of future consumption in terms of present utils. And so now both sides of our equation are expressed in present or discounted utils, and we can compare them. This is exactly what we're saying in this bullet point. Now we can compare the marginal benefit of consumption, more utility, with the marginal cost, less resources, being careful about when those resources are being spent and how do we price that in terms of present units. Now those resources are valued with lambda. That's what we were saying. Lambda is the marginal utility of consumption today. That's the opportunity cost of more consumption tomorrow. So this equation is already telling us about what the trade-off is. If you want more consumption tomorrow, you have to save. And so the opportunity cost of having more consumption tomorrow, it's going to be expressed in terms of the foregone present consumption. You're going to choose consumption tomorrow to equate the marginal benefit to the marginal cost of consuming. We can also express these differently in terms of the marginal rate of substitution between consumption today and consumption tomorrow. The marginal rate of substitution, it's going to be the rate at which the consumer is willing to trade present consumption for future consumption. Note that the MRS is expressed on units of consumption today per units of consumption tomorrow. That makes it comparable to the units of the interest rate, which is in present income with respect to future income. But income and consumption are in the same units, so 1 over 1 plus r is expressed in units of present consumption per unit of future consumption. Now, if the consumer gives up exactly the marginal rate of substitution in units of present consumption for units of future consumption, we know utility doesn't change. Now, markets trade consumption between periods at a rate 1 over 1 plus r. As we explained in the previous video, if the consumer saves 1 over 1 plus r units of consumption today, they get exactly 1 unit of consumption in the future. And so the consumer is willing to trade as long as the marginal rate of substitution is higher than 1 over 1 plus r. That means more consumption tomorrow. Now, as the consumer chooses more and more consumption tomorrow, that's going to reduce the marginal utility of consumption tomorrow. And it's also going to decrease consumption today, which in turn increases the marginal utility of consumption today. So the marginal rate of substitution is going to decrease, and it's going to keep decreasing as long as you keep consuming more tomorrow up until you achieve equality. And that's where you find your optimum. So this is going to be useful because now with this marginal rate of substitution equation, we can think about the effect of the interest rate going up. So imagine R goes up, then the relative price of future consumption is going to go down. Consumer needs to save less today to get the same amount of consumption tomorrow. So saving now becomes a better idea. Then that means that if you at the beginning were equating them, after the interest rate increases, now the marginal rate of substitution is higher at the current levels of consumption today and consumption tomorrow. So the consumer has incentives to trade, to reduce consumption today and increase consumption tomorrow to decrease the value of the marginal rate of substitution and restore equality. Doing so is going to decrease consumption today, savings go up, and then those savings are spent in future consumption. There is also an income effect because the present value of income goes down for the consumer. So the consumer today feels less wealthy, and because of that, there is a reinforcement of the lower present consumption effect. Okay? So we know for certain that the demand for present consumption is going to go down if the interest rate goes up. And this should make sense to us because a higher interest rate is going to incentivize the consumer to save more. With this in mind, we can go and check graphically what the definition of the consumption demand is going to be. The critical thing here is that consumption demand not only depends on the level of the interest rate, it also depends on current real income. If the consumer has more income, then the consumer is going to want to consume more. That's the normal wealth effect that we have studied before in other classes. So the consumer has incentives to consume more and more and more as the real income increases, but we know that consumption has decreasing returns, that the marginal utility of consumption decreases as you consume more of it. And so we know that as the real income increases for the consumer, they want to consume more but a little bit less every time. An important concept is that going to be of the MPC, that's the marginal propensity to consume. And that is, at any given point, if I give the agent more income, what fraction of that income is the agent going to consume? That's the slope of the demand curve. And it's going to tell us how sensitive consumers are to changes in their income. For example, their income can change if they get a tax rebate, or if firms become more productive and they give them higher profits. Now, we not only know this, we also know what the effect is of an increase in the interest rate. We've done this already mathematically with the marginal rate of substitution equation. We know that as the real interest rate increases, say from a low value R1 to a higher value R2, we know that consumption is going to go down. And we know that it's going to go down for any value of income. Because of that, that's a shift of the curve. Remember, an easy way for you to know if something is shifting the curve or moving along the curve is asking if the variable that you're changing originally is in the axis or not. The interest rate is not in the axis. The axis are income and the demand for consumption. And so a change in the interest rate is going to shift the whole curve rather than move you along the curve. Something else that can shift the whole curve is an increase in the present value of wealth. This again, it's going to be because perhaps in the future firms are going to be more productive, and so they're going to give you more profits. That's going to imply a wealth effect that's going to increase consumption for any level of income today. Okay, with that we finish the review of the consumption problem with respect to savings and the derivation of the demand for consumption goods. In the next video, we're going to be looking at the other decision of the household, That is the labor choice. So how much leisure to have and what that implies for labor supply. Thanks.